Hello everyone, and welcome to the Science Tuesday charity checkup, which is a new thing. A new thing that I've bloody gone and done it. That's, well, you see, last time I did the test for my quantum physics video, which is not out yet, I'm finishing it up. It was fun. It was so fun, in fact, that I thought that I should do it again. But with something different this time. Bit more original. And I have something rather original, if I do say so myself. Something radical. Let me just play some music. This is the playlist I used for working on my Ventum engine, so yeah, it should be rather fine, I would say. Is it good? I don't know. I don't think it is. I should probably show you, let me, right? I'll hold you for a second here. I'll hold you. There we go. Should be fine. Okay, so here is here is what we'll be doing today. We'll be doing a thought experiment. That's way more boring than anyone could have imagined. But yes, that's what we'll be doing today. Here's the thing. Recently, a couple of days ago, around 2 days ago, I got, because of a video that I'm working on, I got really excited and really interested in a specific thing in math. That thing being hyperoperations, I do believe that's what they're called. I do believe that they are called hyperoperations. Hyperoperations. Let me just show you. I think. I didn't research anything about them, because it's all... You'll see what I mean. I didn't research anything about them, I just researched their name, because I knew they existed. I have to solve CAPTCHA. I should solve this on stream. Go fund this! Ooh, look, it takes 3 hours for it to load, that's so great! Boss, this is the boss. Yay! Hyperoperations. So hyperoperations are basically operations are basically operations going from incrementation to addition to multiplication to exponentiation and iteration and stuff like that. Now, the reason why I didn't research anything is because I want to do it a bit differently. Which would basically mean I would like to create, let me first check if it's something like this, hyper-operational mathematics. Hyper-operational mathematics. There is no such thing. There's no okay, great. So what I propose is a thought experiment about what would happen if we defined everything in mathematics based on addition. So it would be called then hyper-operational mathematics. That's the idea. And so I would like to write a paper, right? That's why I'm doing this stream. Yeah, because I'm writing paper. That's I know. Listen, normal people have friends. I have papers to write. That's just how it goes. Let me just my second screen. Something's off. Yeah, good enough. The text that tells you to donate to charity is visible. I should probably also. Can I change the theme to dark? That would be no idea. Mode. Google Docs dark theme. Oh, it's something that I have to install. No thanks. Google Chrome. No. Yuck. Firefox all the way. Dark mode Google Docs. If it's possible, I prefer that. I do believe most people like that. Oh, that's that's Chrome. Alright, never mind, we're doing it. I could also do it in Obsidian, but my plugin made by one of my friends, called my my friend, I should say, that allows you to convert Markdown documents to. Yes, it's not working on my PC because I broke it. So my laptop is. All right, finally ready. So this paper is a thought experiment designed to. I'm sorry, I'm trying to sound professional. Give me coffee. I came back from a walk. This paper was supposed to be about something else, something different. It was supposed to be about something that I actually could use in a video, but I went for a walk today, and I realized that I found a couple of interesting things whilst on the walk. So, no, that's what we're doing today. Experiment is a thought experiment designed to simulate what could we achieve if we based all of mathematics on addition. Okay. This is not how I spell addition. I'm bad with words. Addition. No. Adding. Addition. I am an idiot. I misspelled that. Yeah, I did. Addition. Maximum addition. Evolving it using something similar to hyperoperations. So using laws inspired by hyperoperations. These laws will differ from normal definitions because in this scenario we are not restricted to normal mathematical laws whilst at the same time we do not have the comfort of any rules, so we will have to build everything from scratch. Alright, cool. This is right. Yes, scratch. Let's start with. Yep, that's this. There we go. Let's start with things that exist. Like. No, wait, that's. Oh. No, that's a different thing. There we go. Operations. Actually, maybe we should throw operations for later. Yeah, let's. I'm really excited about this hyper-operational mathematics because I think it's a fun concept. I wanted to do it for quite some time, but I was lacking this one part, and now I found this part. The one part that would allow me to actually do this sort of thing. Because normally I shouldn't do it because I don't know enough about math. Yeah, I know calculus. Yeah, I know, probabilities, but it's, well, all of these are kind of basic in comparison to the task. Whilst yes, for some people, solving integrals or derivatives may be complex, it is actually kind of nothing when you compare it to defining the laws of math, defining the actual directions, which okay, this is kind of like if I was trying to do it in normal mathematics, it would be kind of like trying to invent calculus. Very good, but at the same time, you know, not something that can be done by some random guy from YouTube. So instead we are doing this thought experiment, to check what will actually happen. Operations and numbers. I'm doing it just like in the video that I want to upload tomorrow, but I'm fine, it's fine. It's fine. Numbers, things that exist. Irrational numbers. Alright. Things that exist. Concept will be rather simple. We will start with things. We'll start with everything that is true in the real world in order to then build up on it in the hyper operation. So for example, I don't know if I should be adding. It gives me this professional look. This paper is not meant to be professional. It's just purely just me having fun. This is fun in my book, alright? So, numbers. When it comes to numbers, can I use full one? I can, I know I should do. Numbers. One, which will be... So first, which will be integers. All these will be positive. Yes, positive. Negative won't exist, but don't worry, I will not be that radical, you'll soon see what I mean. Positive integers, that will be one thing that exists, then we'll have positive rational numbers, positive irrational numbers. I'm scared my make it WTF. I know they are. Yeah. All of these can exist in the real world. Positive irrational numbers might be controversial, but you will see how I'll define them. So yeah, okay. Integers. Positive integers. Positive integers can be observed in the real world. I will not try to define them, because oh my goodness, is that not easy. Considering that something that might shock most of the people, so because it's very unnatural. Right now we have no rules. Right now I can say anything. I can say x is equal to x plus 1, and that would be true in this world. It would be true here because we have no rules. That would be one of our first rules. And the thing is, when you are defining something, defining some rules, you need to lay out some groundwork that would be unquestionably true. That would be the basis of your stuff. Let me just check if I can do LaTeX in Google Docs. Oh no, there's some. Add-ons. There we go. Add-ons, document add-ons, there's no such thing. There's no such thing. Alright. So, positive integers that can be observed in Word. That can be observed in Word. This will be our groundwork. Can be observed in the real world. Now, operations. We should have started actually defining operations. Operations, that's actually really easy to define. addition. That's the whole point of this experiment, only addition. That will be the only thing we'll define. So, just, no, not list, addition. Addition will be the only defined, will be the only base operation. Sentence primitive, right? Primitive operations. No, it's not. Be the only base operation used to create every other function operation mathematics. I should probably show you right now what got me so excited about this. Paint, the only reasonable tool for explaining anything in this world. It's kind of funny that my videos, you know, I'm using Man in Blender, Premiere, Photoshop, all of those fancy stuff, and when I'm live streaming math, I'm using Paint because, you know, it's a good tool. So what's got me so excited? Well, hyperoperation. Oh, this is basically how it goes. Now, normally notation looks like this: x plus y, that's addition, right? X times y, that's multiplication. X, y, that's exponentiation, and this, that's titration. But the thing is, I don't like this notation because it's a bit misleading. All of, like, this is rotated, this is completely different. It looks like these two are kind of together, right? Like there's some connection between them, and like there's some connection between those two, which I guess is the case, but in reality these are all connected. So what I prefer is to use arrows notation, which is normally used only in exponentiation, but I use it like this: x arrow y, this would be addition. X arrow arrow y will be multiplication. X arrow 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 y, exponentiation, stuff like this. Now you may think right now, this is boring, you are making just stuff up for no reason. There is a reason. There is a very good reason, because you see, when you have x, right? I know why I'm erasing all that. When you have x, you can add something like 2 for it, to it, right? And or you can add 7 or add whatever you want. That makes sense. When you have x, you can multiply it by 10, whatever. You can do whatever you want. But there's one thing that actually stands out. When you have x and you add x to it, what you get is 2 times x. And if you are using the second notation, what you can do is you can do something like this: x arrow x is equal to x times 2. On the other hand, x arrow arrow x, so x times x, is equal to x squared. On the other hand, x to the x, so this, will be equal x titerated. I don't know for titration, it's not really well defined, second. And that's actually kind of insane, because we already got our own kind of equation thing. Well, we have a meta operation definition. No, I'm buttoning stuff. X arrow n arrow x is equal to x arrow n plus 1 arrow 2. That's what got me so excited, because there is a method to the madness. Even though, you know, exponentiation may seem so much different from multiplication, so much different from addition. I mean, for goodness sake, if you multiply x by 0, you get a 0. If you bring x to the 0th power, you get a 1. If we add 0 to the x, what we get is x. It's insane. It goes like this. There is no. It seems like there are no rules to it, but there are rules to it, and that's why I'm so interested. And this is just the beginning, because I knew about this like 3 days ago. I found out about that 3 days ago when I was working the video, and I basically was looking for those rules. But today when I went for a walk, I found something else. So, and because in order to explain that something else, we need to define the entire field to fill up the groundwork for it. So, positive rational numbers. Now, rational numbers can exist really easily based on addition. Because of that, I should actually move this over here, because operations addition, that will be just more important. With the only base operation of mathematics, it works in the exact same way as addition in mathematics. I should do mathematics. It feels kind of weird. I'm saying it feels like I think I'm smart or something. I'm not smart, right? It's just the fact that I'm saying hyper-operational mathematics works in the exact same way as mathematics suggests that no, hyper-operational mathematics would be on the same level. It's not. This is just a dumb thought experiment that I'm doing because, as I said, no friends. Anyway, exact same way as addition in mathematics. And I will not try to define it here, since it's a starting point. Since it's a starting point that is required for everything else. Right now I forgot the term. That's shameful. I thought it was primitive. There's a special group of things in mathematics that is undefinable. There's a base. For example, plane is one of them. You cannot define a plane. Not the flying plane, right? The 2D plane. You cannot define it because based on the plane you define the thing. So anyway, positive integers can be observed in real more positive rational numbers. So positive rational numbers can be defined really easily. It's kind of hard to start somewhere because here's the also interesting fact. Let's go back to plane. Also interesting fact. We right now know that everything in the hyper-operational family exists. So any number of arrows here exists. It just does. It just exists. But what about subtraction? Rather basic. It is rather basic. But where is it? Is it, I don't know, negative 1 arrow? That seems weird. I mean, we don't even know what's happening when we have 0 arrows. So it shouldn't be negative 1 arrow. Subtraction will not be negative 1 arrow. Subtraction will be addition with negative numbers. Now, next thing, division. What's going on when it comes to division? That's a problem. That's a rather big problem. I mean, also, we don't have division. What would it be? Should it be like arrow negative 2 arrow? It's weird. So, because of that, division also doesn't exist. Division is just x multiplied by, when you have a number line. Okay, this is the tricky thing. When you have a number line, you have 1 over here, you have 0 over here, and this goes to infinity, right? Division is mapping this entire thing. It's mapping it over here. That's division. The point is, all of those weird... So basically this would be y, but mapped. The point is, all of those not defined operations, like subtraction, like division, like roots, all of them, their definitions depend on themselves. For example, definition of a square root, right? When you have a square root of n is something that when multiplied by a square root gives you n. That's how square roots work, obviously. When you have n divided by square root of n is equal to square root of n. That's how square roots work. The problem is, there isn't really a different good way to define square roots. This is the best definition of square roots there are. And you have to realize that square roots, in order to define... I know, I must sound like great. In order to define the square root, you already need a square root. Because of that, square roots are kind of this weird thing. Where you have, for example, 3 to some power, you can calculate that rather in a relatively easy way. For example, x to some power like... You can calculate that. It wouldn't be easy, but there are methods for doing it. On the other hand, when you have a root of x, even a square root, not even, I won't even bother with 10,000. Even a square root of x, it's starting to get a bit tricky. It's starting to get a bit tricky because what you are doing is you are mostly approximating. Because, yeah, it's not as convenient. Most of the time when you have a square root, it's just that you just know it like this in the equation. Because powers are just way better to work with than roots. You never see, when you have equations, you never see something like this, like just left alone in the equation, because it's really hard to work with something like that. So instead what you do is you do x to the power of 1/3, and all of a sudden it's much nicer. So the whole point later on of this hyper-operational mathematics project of mine will be that basically there is a method to the madness, because very important thing, tetration is not defined correctly. It's not. And it's not that I'm saying, you know, some kind of hot take, ooh, tetration is not defined correctly with those mathematicians. No, it's just not. It wasn't a useful enough operation to get a full definition. So if I show you right now this page, it is defined for, first of all, only for positive numbers. Right? Yeah. Yes, it is defined only for positive. There is no standard notation of tetration. Definition. Unless I misread, that's what I'm double checking right now. Before pentation, yeah. Yeah, but iteration, is there iteration for... Ah, yes. As for, I guess, no, other are just areas of active research. So yeah, it has recursive definition, stuff like that. You cannot really have anything for rational, irrational, you know, complex iterations. You can really have that. And so that's kind of the goal of this experiment. To create a definition for tetration whilst not trying to create definition for tetration. Because if we do that, then we will have definition for every single hyperoperation. We'll have definition for tetration, for pentation, for every single other one, which will be really convenient, because then we could reliably predict what's going to happen. It's, as I said, it's not easy. It's not an easy project, but that's why I'm doing hyperoperational mathematics. No math. Because when you decide the rules, the task is easier. Can be observed in the real world. Yeah, okay, we'll get to definitions of normal stuff. Actually, no one's watching, I can do it right now. Can be observed in the real world. And let me just check. Oh, come on! No, I've been banned from... No, give me a second. No! You are not real. I refuse to believe that. That's awful. That is... No. 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 No! Oh, that's so sad. My VPN was just banned by Open. Oh, but by Open. No. Oh, and I logged in on the wrong account. Fudge! Oh, it's so bad. No, don't sign up. Oh. I'm sorry. I'm just trying to pick up the term for things that are undefined. No. It's just easier to do it this way than to sell. That's the point of GPT. Alright.
He sent the print to the station. And Brown, he's film director at the station. I know, you're trying to make me the ball guy. And Harris, projectionist at the station. I only had that print long enough to thread her up.
Right, great. Great. Now let's just. I'm off. What is the name of things in the map that do not have a definition and are a base for defining every
All we got are suspects. My job?
else. Alright, cool. I'm back! Something went wrong. Oh no. Ah! I'm sorry, I'll have. Oh no. I'll have to turn off my VPN every single time I want to ask ChatGPT a question. Oh, that's awful. Oh, that's awful. Oh, I'm torn. I love VPNs. I don't care what Tom Scott says. I know computers very well, and I also know that I need a VPN. Because every single time I see a weird link on Discord, I open it every single goddamn time. The only problem being that I open it in the, well, not the problem, the only good being that I open it in the correct way. What is the name of things in the map that do not have a definition and exist as a base for defining everything else? Primitive axioms. So what do those axioms?
Stick to their stories. We're stuck with a perfect crime. It happens.
Axiom.
More than you think.
Axioms. Wikipedia. Axiom. Postulate, assumption, statement that is taken to be true, so a first starting point for. Alright, so we will basically have. I am back. Things that exist. Operation. The end page of Russian mathematics. It is one of the three hyper operation. Hyper operation mathematics. Axioms. This is bold. I don't know what's bold. Axioms. So I will not try to define it. Yep. The other two axioms will be the numbers axiom and the building axiom, which basically means that two other axioms will be that positive integers, rational numbers, and irrational numbers exist, and that we can create other things that are true based on things that are already true. Those will be our three axioms. So that's convenient. That's very much convenient. Glad, cool. Let me just copy. Ah. numbers here are exist based based on the. I'm sorry, I am so very sorry, that was awful of me. Alright, let me just exist based on the numbers axiom. On the numbers axiom. Make bold. Actually make bold, yeah. Numbers axiom. So that's really convenient. The convenient thing about axioms is that you know how to define them. The inconvenient thing is that if you have too many of them, they may contradict each other and then you are screwed. If you say that 1 is equal to 1 and then you say as an axiom and then you say that 1 is equal to -1 as an axiom, you know, that's a bad example. If you say that, well, 1 is equal to 1 and 1 is equal to 2, then you are heading in the direction of many problems. Yes. Because based on, if you have like two of these axioms that contradict, then yeah. Based on numbers axiom. I should probably define also the axioms better. Things that exists. I should define them like over here. Actually, rational and irrational. I don't know how to define them. So, things that exists. So, axioms will have the operation axiom, then we'll have the numbers axiom, then we'll have the evolution axiom. We're starting with the boring stuff, alright, before we get into the actual fun bit. Operations axiom. The only operation defined by this axiom is axiom. I'm explaining that word looks weird. Is addition. You know, defining addition based only on addition will not be easy. But you know it when you see it, will not walk you, right? I love science though. I love science. That's not a joke. I do love science. It's just that these first steps will not be easy, because defining stuff like this. So basically, you know, lattice in here, right? I'm pretty certain we can do lattice inside operations. I mean equation, yes. So omega. There we go. Now we are gaming. Cool. X is equal to. So like, how do we do it? A plus B is equal to C. Yep, we will. This, if that is the case, right? If that is the case, A plus B is equal to C. That means that B plus A is also equal to C. That's, yeah, that's reasonable addition. Then what we also say that is I should use the arrows, and now I remember why I want to use Ladix. Up arrow. There we go. Addition. There we go. So, yes, now subtraction. That's the hard bit to explain, considering that doesn't exist yet. It doesn't exist. The only thing we have right now is addition, that's it. I shouldn't redefine addition. I cannot redefine addition. It's the first axiom. I don't have numbers yet, so that's the best definition of addition we have.
Hello? Bring up the boys, man. Tell them meet me at Pine Creek Forks. Flying V payroll's been robbed. Pete Bell has been kidnapped. Tell the boys to ride.
Alright, so the only predefined business axiom is addition, which is symmetric. No, symmetric. Actually, symmetric. Symmetric would look something more like this: A B is equal to C, and A up arrow E is also symmetric. Actually, I think should be over here. So which is not symmetric in this case. Is fully equal sounds really dumb. I'm trying to do it right, because I know if I mess up in the beginning, then I'll have wrong axioms and then everything will get screwed up. It's a rather big thing for me, alright? I don't do good math often. Last thing I did when it comes to actual math was, well, that was quantum physics. But before quantum physics, that was the Boltzmann equation. The Boltzmann equation sucks. It does. It sucks. It's fun because not many people can say that they did something like the Boltzmann equation, but it still sucks. It's still ain't great. It is truly equal. So like this. I should probably add colors to this for easy reading, because oh my goodness, is it unreadable so far. No, fuck. I'm gonna do it correctly, okay? Equal.
Where's the Flying V payroll?
So if is equal to C, then there is no okay, value difference in between and C. Yes. Symmetric. So that it's equal to A up arrow B. I know there will be people online that will be mad at me for even trying this, but you know, screw them. And those are two that we need right now, right? Yeah. truly cool symmetric, that's good enough for now. We aren't actually defining addition because it's not as easy as it may seem. Just try to define addition. It's kind of like explaining color to a blind person, right? That's why axioms exist. So. Addition, numbers axiom. The only numbers that truly exist. Actually, I have one better for this. This axiom comes in two parts. One. The only numbers that truly exist over all hyper operations are positive integers. Actually, integers by themselves. No, integers, yes. Integers. We will need second, which will be every other number exists only in relation to a given hyper operation. Yes. This one would be extremely hard to explain with just mathematical notation because of how different this from normal mathematics. It would make no sense. That's why I have to think. Integers. So, for example, A is equal to C. Up arrow 20 is equal to C. Actually, let's do it like number 15 is equal to C. So basically they exist everywhere. Yes, they exist everywhere and it is possible for them to be anywhere. Exist in relation to a given hyperoperation. I love this idea. Some people might consider it dumb, but I love it. Basically, let's take for example a half. We have a half, right? Half plus half gives you 1. So what we can do in normal math, then what we say is that if we take some number x plus x, if it equals to 1, then x has to be equal to a half. But in hyper-operational mathematics, what we can say is that when we have a half operation, random operation will be basically just arrow, dot, 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 arrow. So h, half, some operation half is equal to 1. Then what we say, actually, let's do it up and up. This will tell us like what operation are we talking about. Up and up. Yeah, h is equal to 1. What this will tell us is that based on what hyperoperation, what is a half. So for example, if for h up h is equal to 1, half, so for addition, this is a half. For example, for multiplication, this is a half, 1. What's also amazing is that if we do it like this, what we can do is we can also define half of some number a, and then for example ha, some operation n, operation h a is equal to a. That tells us what is the half of given number based on one operation. So for example, when we're talking about the first type of operation, addition, right? When we are talking about addition, half of a 2, right? would be, so half of 2. I should do it with the hat. I feel like with the hat it would be better to don't get it mixed up with anything else. I feel like that's just quantum physics talking to my veins, but hat 2 or in addition. Hat 2 of addition is equal to 1. So half of 2 in addition is 1. On the other hand, half of 2 in the multiplication is square root of 2. I love this rule. I love this rule because it's so different and it still makes so much sense. So because we went the other way. In normal mathematics, people basically started with a half and a 1, started with addition and the sum, and based on that they defined a half. In our case, we start with the half, and we defined I love it! I love this definition. Every odd number exists. For example, a half. Based on the previous axioms, we can say that a half. So this would be fraction. So for example, 1. In mathematics, hyperoperational, that sounds so much fun. Mathematics, we can say that yes, this. Hey David. Hey David. I don't know why I said it the weirdest first time. I'm really sorry. Hi there, how you doing? Once again, I'm doing not that interesting stuff. Let's be real. I'm writing a paper on the stream. My laugh is really sad this morning. Later on, I'll be streaming Subnautica. I feel like recently, every single time you tune in is just, you know, me doing something extremely boring. I am very sorry about that. Oh no, last time I was doing quantum physics. I'm really sorry. I'll try the swimming one just then. Oh, that's... Oh, yeah, which... back to defining axioms. We can say that hat, a very cool function in... Not function, operator. H hat. Oh, why is this hat so high up? H hat, up arrow, H hat. I'm doing pretty good. Doing some last minute thing pattern for. Oh my goodness! Oh, you are just so casually dropping this big piece of information. So sick. I'm excited for you. I mean, it's. I hope I hope you're enjoying it because flight to Korea is pretty fun. That's a big. Wait, how last minute cleaning and packing? Okay, but I need some time scale. Is it like, I don't know, this week or this hour or when exactly I'm flying? I need some time scale. Yeah, because. You got me really excited. It's not converter. So it cannot exist. Over 3 a.m. Wednesday morning for US Central Time. US Central Time. 3 a.m. Wednesday morning. All right. 3 a.m. That's all right. I'm zones. Time zone converter. Oh, I love that someone out there made that. So convenient. That is not the time zone converter that I thought. There we go. Local time. There we go. US Central Time. Can convert the other way. That's great. Local time. Can I go from last one? No, that's not how it works. Ah, fudge. Check the time zones. I mean, it's, you have to understand how cool is it that you are just so casual about this. Yeah, just flying in Korea, you know. Alright, time zone check. Yeah, I know I'm +1, but then I'm doing the old way. The you know, back in my day, that's how I used to check the time zones. US Central Time, I'm guessing that's -6. I'll be off. The worst case scenario, I'll be off by 1 hour, unless US Central Time is based on Washington. That would make sense. -5. Okay, so that would be the same as France. So let me just France. Good enough. Oh yeah, so it is 10 a.m. So it'll be 10 a.m. for me Wednesday. For me, alright. Let's see, it's 5th. I shouldn't have this much trouble with this. I mean, right, so I don't know why I even checked the date. I'm sorry, you really got me flabbergasted there. It's so okay. So tomorrow 10 a.m. That's great. I mean, that's great. That's great. I'm just pretty casual. Yeah, I can tell. That is a very good quality. You know, I respect that so very much. I respect that so very much. That's so sick. I, as you can tell, am also very casual, and I am also very calm. I'm a very calm person, and I don't, you know, get excited easily and stuff. And so I'm very happy for you. I am very happy for you because that sounds pretty amazing. You will quite literally fly half the world. It's great. I'm not a person to know a lot about geography, unfortunately, so I will not spice up some, you know, cool facts. I'm pretend you know more about Korean guy because I don't know nothing. So I don't know what I'm flabbergasted. That's I need. Alright, muff. Yes, muff. Alright, calm stuff, muff. So, by the way, yeah, I'm glad you're doing something exciting. I'm just, you know, we'll make it just redefining mathematics on stream whilst writing a paper. This is the saddest sentence I've ever said. Integers, so it cannot exist over all hyper operations. I'm sorry for you know, so getting back to writing this, but I do kind of need to finish it today. I would like to finish it on stream. bald eye. Alright. Ah! You really got me flabbergasted. Okay, hyperoperations. Yes. Cannot exist over all hyperoperations. So, for example, which means that... I'm sorry, I just looked over on my second screen for a second, where I have my stream statistics. David, I have a question for you. Do you maybe know by per any chance, do you maybe have an idea of what this is? Didn't get a chance to live, unfortunately. Well, yeah, I mean, well, I guess they had a couple of interesting moments, like that time I died. Or when I went denial. David, do you perchance know maybe something about this? Is it something that you are aware of? Is it like is it related to you in any way, shape or form? Is it something that these are stream statistics of, you know, time and people watching? I'm just wondering, out of curiosity, out of complete curiosity. If, you know, considering that normally I've, on average, about one person watching. So this would be not equal? Is it the way you define it? No. Not equal? Oh, come on, LaTeX. LaTeX, come on. So, how do you... Not equal in LaTeX. NEQ. Apparently, wait, what? NEQ. That is very much not right. NE. NE, there we go. So... What? Oh, I can also the hearts. Number of views received? Yeah, it just randomly jumped up to 7 the moment you, a couple months after you joined. Just you know, just randomly went up to 7. I was just wondering if it was in any way, shape, or form related. Just all right. What? I know it's me being still flabbergasted. Oh. Ah. Actually, I need the opposite of coffee. I need some tea. I don't know what's the opposite of coffee. Never drank it. I'm usually the one that needs energy. All right. Because. Well, oh no, that's as a screen. Wrong thing. That's because H hat, which will be the half for second hyperoperation. H hat, there we go. Up. There are 5 people at Singapore watching the stream. Yeah, it said that it was 7, which is, you know, a bit more than. Oh no, I'm still. There we go. Which is a bit more than my usual 1. Up arrow. Up arrow, up arrow. Hat, H is equal to 1. and then a hut H, up arrow, hut H, yes. Is that because H up arrow H is equal to H up arrow H? Does that make sense? Doesn't. It does not. But I don't know. Does it make sense? It's really complex. Well, it's not really. I can explain it rather relatively easily. It's just I'm trying to find different sort of mathematics here. Okay, evolution axiom, which I should actually define before numbers, but oh well. Evolution axiom, also rather simple, because why is it lower down? Oh, it's because it's numbers axiom. Yeah, that makes sense. This is starting to look pretty decent, pretty professional. Team is growing slowly then. Yes. This is like a month-long record. No, not the month-long record. We did have the pretty big... No, wait, the 50 daily charity checkup. The daily charity checkup number 50 had, I think, 6 or 5 people watching at best. So this actually might be a month-long record. Wow. Oh, damn. That took me by surprise. I don't have anything interesting prepared. It's just a freaking math live stream where I'm writing stuff and drawing in paint. I don't have anything interesting or entertaining. Oh my god, I'm so unprepared. What sticks? Okay, let's do. I don't know. Math. That's the only thing I know how to do. Lucky entertainment. Okay, evolution axiom. Evolution axiom dictates that we can derive. Would derive would be realistic? Yeah, derive. I guess. I don't mean derivatives. I mean derive. Derive. Define. Battle of words. This comes as an extension modification. Another concept. Derive. True definitions based on true operations based on hyper operations based on the underlying true base operations. Does that make sense? It doesn't. It's just I sound like scientists who are trying to sound smart because well, yeah. What I'm writing here is not as smart. It's actually kind of not smart. I am defining my own mathematics, so it's kind of cheat code. Yes. There's a test called the ASVB, which can take for joining the military. I'm sure you will score any job you want, lol. Well, that may be true, but no. Military requires a lot more than I have to offer. A lot more than I have to offer. Whilst I suppose, I mean, okay, whilst I am relatively... I don't know if I should call myself smart. I don't think I am that smart. I still believe that I am not smart, only most of the actually smart people out there have no idea how to teach others. So that the knowledge is, scary and stuff, like integrals, derivatives, for example. But at the same time, I am decently certain that in military, there are there are more important things, like honor, for example. I am a YouTuber. I know nothing about honor. I don't have a moral... I'm a YouTuber, I don't have a moral compass, we don't do that here. Okay, so being in the military requires different values than I do. I don't think I have these kind of values. Like, for example, you are a very calm person, and because of that, you can handle a lot. That's why I did say that, I respect you for that tremendously, because that is an amazing thing, an amazing skill to have. Being able to stay calm under pressure and or calm in general. You're very casually saying, yeah, we basically, flying to Korea tomorrow and stuff like that. So that's a very important thing. I, on the other hand, don't have that. I cannot stay calm under pressure. Whilst I don't break, I am very much not a calm person. You just came here, told me we're flying to Korea, and I was flabbergasted. I don't bewildered. I don't know what other synonym to throw in this scenario, because I think I would just, I don't know, flip. It makes me relatively entertaining because I can react in funny ways to stuff. For example, when I'm playing a game and I see a giant monster swimming to me, about to wreck my ship. I'm not saying that happened, but I'm saying that if it were to happen, it wouldn't be the first time. Then I may react in a way that is rather silly. Hello everyone and welcome to yet another video in which Make It tries to explain something but is unable to. I'm so glad that Wow, I still drink coffee. I really should not be drinking at this point. I already got my daily dose of chemicals to wake me up in my brain. Serotonin and other enzymes, I don't know what they're called. So yeah, in my opinion, I still believe you are a better person than me, and so whilst I could score on this test that you mentioned pretty high, I don't think that tests are everything, because tests don't reflect on reality that well. Fitness test is really easy, and you'll be surprised. The main thing you need is integrity and doing the right thing. Integrity. Well, listen, you are talking to a YouTuber about integrity. I don't have integrity. But yeah, and doing the right thing. I mean, here's the thing. Okay. Whilst it may seem that what I'm doing is really smart and stuff, it's very not. Take this for example. This line right here. Seems rather complex, right? I mean, look at this notation. It's insane. It is insane. It has stuff like, it is basically h hat up h hat is equal to h hat up h hat. Some crazy stuff. What this means in actuality, what this actually means, is square root of 2 times square root of 2 is equal. Well, actually, not 2. I'm sorry. I didn't know. 1 times 1 is equal to 1/2 plus 1/2. This is what it actually means. The only difference is that this is just different notation. It's the same thing, except it's different notation. And most of the time when I'm doing stuff, they require weird notation whilst being extremely simple. So because of that, it seems like I'm very smart. Because, I'm doing stuff like, I don't know, solving integrals that look like this from quantum physics, psi, convolution x, this, dx, which is equal to expected position. Wow, that's really insane. And until you watch a 3-hour lecture about this and you realize that it just means that particle cannot be. Okay, this is a bad example. I picked a bad example. Let's pick something else. Integral of x squared. Great. What all of this means is that when you have x squared, let's say from a to b, to make it even more complex, when you have x squared, which if I'm not mistaken looks like this, when you have point A, point B, this is the integral, this area right here, which is extremely simple, I would say, but it hides behind this very scary notation, like integrals, dx and stuff like that. And because of that, I'm actually not that smart. At least I'm honest. Yeah, well, kind of the only thing I've learned to this, honestly. The problem is that there are so many people out there who aren't honest about this little thing. And they want to seem smart. So, here's the thing. Here's the thing. When you find someone out there who's using extremely complicated words And if they are trying to convince you that these words are complicated, that means they are not actually smart. So if you find someone out there who's telling you stuff like, and then basically you take the antiderivative or the integral of psi complex convolution x psi, then you get the expected value of x. That means they are not actually smart, and they are only trying to sound smart, because actually smart people they know their shit. Let's the simplest way possible to put this in the simplest way possible. They know their shit. They know what they are talking about, and because of that, they would try to explain it. They would explain it correctly. And I just want to let people know that the ones that want fudge. I'm very good with words. I'm so glad my job is quite literally talking to people. I'm so good with words. So my kind of mission is to convince people that they are more intelligent than they actually are. For example, I do believe that you are way more intelligent than you are letting yourself think that you are. It's just that you have different values, and because of that you don't actually pursue just the intelligence, which is very reasonable in my opinion. It is very... I think if you actually try to learn quantum physics, you could. It wouldn't be hard to you. The problem is that learning quantum physics is a useless skill. It's very much useless. It's cool to say, oh well, I know how to do quantum physics, but that's it. It's just something I can say. It's not useful in any way, shape or form. And because of that, I do believe that stuff like, joining the military, doing the right thing, and having integrity, that's more important than just learning how to do stuff like this. Because this actually kind of gives you nothing, I can say from experience. So whilst, yeah, having intelligence scoring high on tests, that's cool if you don't have values. So it's really good that you do have values. It's well, by definition, having values is very good. So I'm not certain. I mean, I guess maybe there are parts of the world where I could go score high on a test and get any job I would want, but then people would hate me for that. And having money is neat, but not when everyone hates you. So yeah, I don't think intelligence by itself is important. Soon we'll build machines that will think for us, so... Well, we do have computers already, but I mean AGIs, so yeah, intelligence, it's a meh. It's a meh. Anyway, back to math. Wow, I went on an adventure there when it comes to different topics. Wow. Well, yeah, evolution axiom. Evolution axiom is rather simple. True hyperoperation that we can derive based on allowing true operations. For example, I do feel as if I'm pretty smart, but you explained it perfectly. Yeah, like you are pretty... Okay, the pretty smart means that you are smart, except, you didn't actually pursue anything to only achieve intelligence because you were focused on other more important stuff. Unfortunately. Yeah, exactly. Now imagine doing the same thing with fucking calculus. Calculus is one of those things that looks very impressive, but is simple and useless 90% of the time. Unless you are a mathematician, then calculus is useless. And I am just here to explain that, people who know calculus aren't better than anyone else. They are not better. Knowing calculus is like knowing anything else out there. So yeah, that's the thing with scoring a test. Yeah, I think I explained my point. reasonably well. I should get back to this. I'm sorry, I'm not formatting stuff. I haven't wrote a paper in a really long time. And the last paper we wrote sucked. I'm pretty certain it's still on my website, because I copied everything. You cannot access it normally. Whoops. You cannot access it normally, you have to hack your way to it. Docs, if I'm not mistaken. Oh, not docs. Dissertations? Nope. Or maybe it's gone. I don't care what are required for my goals. Well, I mean, yeah, I guess sometimes, I guess sometimes you do are forced to learn stuff that, you know, aren't required for goals, but at the same time, if it's not actually, I mean, if you have to learn something just to learn it, not to actually know it, like in schools, let's be real, schools, 90% of, well, more than 90%, almost everything you learn at schools is only necessary so that you can finish school, because later on you will not use it. Those things are annoying, but they aren't actually that hurtful in the long run. So, yeah, So, yeah, temporarily they will be annoying, but at some point they'll be gone, and you know, you will advance in your career, and you will be able to choose what would do you actually require for your goals, and you'll be able to do stuff that only interests you. I'm sorry, I started thinking about how I'm a YouTuber and don't have the time for my life. Yeah. Anyway. Okay. Oh yeah, last Explorer desktop projects, site, public, dissertations. Which one is it? No idea. Let's open up an Explorer. Derivatives. I'm pretty certain that's the last paper I wrote. Is it the complete one? No idea. It's a paper I wrote whilst learning calculus, about calculus. It's not complete. Very much incomplete. If I went digging, I could probably find it in my Google Docs, but yeah, so I haven't wrote a paper for quite some time, and this is a rather big one. So for example, X up arrow, like this, X up arrow, X is equal to X up arrow 3. Now it's time for the actually interesting part. After things that exists, we can do another header, which will be expanding the field. Expanding the field. Now that all of the axioms are established, we can finally start. We can finally start creating deriving definitions. It's not a reference to derivatives, it's just a word that normally is used in English. So, first of all, we can generalize the evolution axiom example. Now, I am not actually that certain how to define it. It's just that x arrow x is equal to x arrow 2. so dot 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 and dot dot dot. I know that is true. That's kind of the point. And plus 1. Dot dot. I know dot 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 is required every single time. Actually, yeah, it is. Not, it feels a bit. A lot of stuff. It feels like there's a lot of stuff going on here. I should clean this up a bit. There we go. Brackets seem cleaner. I want this to be a readable example. So this is the generalized formula for the evolution axiom, and x arrow. Yeah. So basically, well, here's the thing. Normally when it comes to arrows, because arrow notation exists. Normally arrows are used for exponentials. So x arrow x, that's x to the power of x, and that's what the arrow means. Now I'm here creating my own math. So basically arrow means addition, x plus x, and it just so happens that the thing I've written down, so x arrow n arrow x is equal to x n plus 1 arrow x, I mean 2, and you can okay, but this is way simpler than it seems. So basically what this means, it's a true fact too. So basically when you have addition x plus x, right, x plus x, that's equal to x times 2, or in other words, x times 2, and you can keep repeating that. X times x is equal to x squared. It's just a different notation, and that's what I've written here. So x some number of arrows, n some number of arrows, x will be equal to x the number of arrows plus 1, 2. And that does check out, because x plus x is equal to 2x, x times x is equal to x squared. There's always this 2 here. X to the power of x is equal to x tetrated, which is actually a different operation, which is weird, which is not defined by math, which is why I'm doing this entire really weird thing. This is actually really weird. This is very much not normal math. So, action example. Now this by itself is rather, well, not complicated. It's clunky. It's rather clunky and unhelpful. Clunky and unhelpful. So we will need some different set. That's spoken infinity. Yeah, exactly. That's why I said in the beginning of this paper. For the experiment, designed. Well, I use a lot of weird words. I hate myself for that. What happens if we based all mathematics on addition? So this is basically an experiment for what would happen if subtraction. Where's my? There it is. Subtraction didn't exist. If you know, subtraction, there's all of those weird stuff. What happens if they basically didn't exist at all? And the only thing we have is addition, and that's actually it. Addition. That's the only thing we have. And so based on addition, we can create multiplication, exponentiation, titration, but we cannot create subtraction. That's, for example, interesting. It is impossible to create subtraction, and that's what I'll also attempt to prove. I'll also attempt to. Okay, it is really nerdy. It is extremely nerdy, and the reaction of most people would be why, and my answer that would be because I'm bored. There's absolutely no other reason. It's dumb. It's hard to explain, and it is borderline completely useless. Oh, I'm so glad you understand, because I am not doing a good job explaining it at all. drawing this randomization. So different sets of generalized definitions to help us. For example, let's start with a half. We know that half can only be defined in relation to an operation. I feel like I'm stealing it a bit from quantum physics. In quantum physics there are operators which can only act upon a function. Once again, I'm using these complex words for no reason. It's just, I'm trying to lose faith in this because it just feels like every single time you are writing something, you are using way more complex language than you need to. And it's so weird. Alright, you know that half can only be defined in relation to an operation. So for example, yeah, actually I said already over here. Operation, yes. Now what? Now we could check what are the values of those halves. It's like saying if math was only able to solve. Yes, that's exactly true actually, yes. Because the problem is that when you have all of these different equations, when you have all those different operations like roots, like logarithms and stuff like that, most of them are kind of uncalculatable. It's okay, it's a weird thing to say, but most of them are really hard to calculate. For example, when it comes to exponents, right? So when you have x to the 7th power, you know that this is just equal to x, or that was top 10 x's, x times x times x times x, and this 7 times. 1, 2, 3, 4, 5, 6, 7. We know that. On the other hand, when you have the square root of x7, there is no real way to actually write this. Square root is as good as it gets. That's why, for example, square root of 2 is the simplest way to write this thing. Square root of 2. Yes, these numbers go irrational because there's no easy way to write this down. Square root of 2 is the best that you get. And so because of that, I'm wondering what will happen to math if we couldn't do these things. If we had to do it the simple way. It means that I'll have to lay out a lot more groundwork, but in the end, the definition should be way better. And I'm also doing it with addition that works in math, so that's handy. That means we'll integrate into the math. Alright. Let's do the operation. Yes. So let's change up its notation to reflect. Let's create a function that would return a half of a given number in relation to a specific operation, which would look like this. It would be h hat function n of x. That is a great function. Wow, it definitely doesn't look complex. Where you say I'm understanding it now. That is impressive. That is very impressive because this is basically my madness on the paper. Where n, alright, let's do it bold. N is equal to the index of once again I'm using index. Why not just normal words? It's like index of an operation. 1 for addition, 2 for multiplication, 3. I'll let you be the subject matter expert and I'll save myself the piece. The really convenient thing is that I am like creating this, so it's as dumb as it is. I can say right now that I'm the world's best expert when it comes to hyper-operational mathematics because I made the thing. I made the thing up. It's silly, it's useless, but I can still call myself an expert. That's funny. So it's not actually done yet. So okay. For exponentiation, ... Yep. Where and x is the number operated on, yes. I should probably come to that, and should be different color for the readability. Red, good enough. Okay, so the color of latex. Can we? Wait, we cannot. We so very much cannot. Yeah, that seems too good to be true. 1 for addition to multiplication, extension, yes. Now we can. Now, in order to increase. Now, in order to understand this approach, let's generate a table of different inputs in relation to different hyper operations, and what are they equal to in normal mathematics. Now let's insert the table. We will do for, okay, this will be addition, multiplication. Now let's do iteration, and let's do for like 5 numbers. That's good. Actually, I screwed up already. Fudge! Why am I like this? Why am I like this? Table! We need 5 of them, I mean, obviously. 5? Yeah, good enough. So, this will be addition, multiplication, n equal to 1, so addition, n equal to 2, multiplication, exponentiation, titration. This will be a hard one. 3, 4. Now, oh boy, generating halves for different numbers. So 1, 2, 3, 4. It's really tempting to just do 3, 4, but I feel like we should also do. Actually, let's do 3, 4. Yeah, fine. So for n1, we are looking for a number. So number plus a number is equal to this, which means.
Suppose Mr. Grimes had tried another approach.
Yes. Looking for a number, so fraction. Fraction. 1/2. This will be our half. Over here, this would be 2 halves. Over here, it will be 3 halves. Why did it jump to the... it's so upsetting. 4 halves. Yes. In n equals 2, this would be square root of 1, square root of 2, square root of 3, square root of 4. In n equals 3, we would need to trace it. Oh, I don't know if we can get up to... Give me a second. I'll be right back. I just need to... Oh boy. Alright, I'm back. Oh, fudge. Okay, good. Now, for N3 and 4, we are starting to have a problem. Because in normal math, we have no idea what this. So we are looking for N3, we are looking for a number, so that when we bring it up to its own power, we can calculate that. We can do it. So what we need, oh fudge, this one. Let's do it. X to the x. We are looking x to the x is equal to 1. That's 1. That is just 1. So 1. Then x to the x is equal to 2. This is not an easy thing to calculate though. Over here is really not. Because when you have x to the x, this could be equal to e to the natural log of x to the x. Will be then equal to e x to the natural log of a. Okay, what now? Well now, oh fudge, this is fun. E to the x natural log of x. Let me double check with Desmos. I love the fact that Desmos is just free online available. There we go. Ah, come on. I swear. Make it versus capture. Give me. See so. Right. Make it versus capture. Part 2. And you consider it to be fun. Well, alright. Okay, 1 is equal to 1, that's true. 1 is equal to 2, 4. Which means that, oh, this would, so this is a d, this is the x to dx function. I'm sorry, you just sounded a bit fun. You consider it to be fun. I get the idea. It is not something that normal people would consider fun. Alright, what we are looking for is something, and when it is, okay, so, x, right? Wait, what are the, what exactly? I'm lost now. X to the x that is equal to 2. Which one is equal to 4? Wait, is it increasing? No, wait, what? That's 2 to 2. What's equal to? Oh, it's over here. Yeah, well, yeah. That, I mean, maybe I am a bot, you would never know. X equal 2 was the solve for X, Wolfram Alpha. I love this tool, it's amazing. I was correct. Fudge, I was correct. It is e to the power. We don't care about the rest of solutions. Well, we will care about them, but not for now. X equal to this. Protect the... oh wow, that was, I was really loud there. I love that. So what this basically means is that when x natural log of x, right, this is still equal, so 1/2, so then e squared natural log of x. I want to make sure that I am not mistaken with it. Multiplying powers rules. I add to is reset before I do the thing. Alright, that is true. So here's the thing. Can I, if I do it like e squared times e to the natural log of x? No, because these are multiplied. Oh, fudge! I forgot. These are multiplied, not added. So it would be actually e to the natural log of x times e to the natural log of x, which gets us nowhere, because after we cancel it's x times... No, wait, it's not x times x. Oh, because we are solving for 2. So when we are solving for 2, this is equal to e the natural log of 2 times e to the natural log of 2. Oh, because I added 2 in when I shouldn't have added 2 in. What I should have done is solve for it. Ah, yay, this is fun! I know who will have the answer. I knew it!
This video is brought to you by Brenda Walk.
I knew it! Black pen, red pen's a child. I knew it. Don't trust Blue from Alpha, trust... Oh, this will be so fun. What? I am not so... Oh, no, because new account, I forgot. Okay. I would love to watch it. I genuinely would love to watch it. The problem is I'm watching it on stream, and I really don't want to steal Black and Red Pin's content. Yeah, so it is with W. And if it is with W, that means we do need to learn what this means. Alright, what's the product log? I don't like that. I don't like that one bit. Because this will be really difficult. Note. This was solution for W in Z is equal to WEW. So it would be like... natural log except... And I'm not misunderstanding this. Imaginary parts from a yes. Lambda W function, now we're talking. Omega now we're getting into fun territory. I was just dropping in the chat with focusing on cleaning. Yep, don't worry, David. See you. Glad you could. Glad you could. Now we're getting into really boring bits, so you know, run, save yourself. Good luck packing, though. Good luck. I mean, I don't know why I say good luck. Good luck was just that you need that. Like, you know. I don't know what I actually say in this situation. I'm not good with social interactions. Let's just go back to math. Let's just go back to math. Alright. For each integer k, there's one branch noted by WKZ, which is a complex valued function of one complex argument. Principal branch. I really dislike how long this is. Welcome to the math. Principal branch is noted by digital library of mathematical functions. Give me this, please. History, I don't care about history, just... Lambert is considered related to Lambert's differential equation, which led to an article by Lawrence. Oh, I know this guy. No, fudge. X is equal to x to the m plus q. Let's transform this equation into the form x to the a minus x to the b is equal to a minus b cx 8 plus b. Equation, because in case a is equal to b, taking in limits, you derive the equation natural log of x is equal to cx to the a. A is equal to 0, and then convergent series solution for the resulting equation expressing x in terms of c.
As long as we're alive, we got a chance. We got to find a flaw in his plan.
There are countably many branches, that's actually interesting, of the W function, noted by W. Here's the main principal branch. K is equal to 0, defined as non-zero Z. I still, it's amazing how much you can read and still not know what it does. Some manipulation, you're not telling me what, man. The standard form Lambert function is obtained. In 1993, it was reported that Lambert W function provides an exact solution to the quantum mechanical double-whale Dirac delta function model for equal charges. Alright. Definition of the Lambert W function. Oh, it's tempting, but I don't wanna steal Lupin's Red Pen's content. He taught me calculus. As the inverse of f of x is equal to x to the... Oh no, oh, I get it now. Oh no, that hurts so much. Oh fudge, no. Oh no, oh no. It's like normal log. Oh, that's so terrible. So basically, okay, here's how normal logarithm works, right? We have a to the b. Right, solving for b. Actually, wait, does it? No, it does not. Oh, no, x is equal to... Yeah, it does. It does. Oh, fudge. Y is equal to a to the b. If I'm not mistaken, log a y is equal to b, right? And this is the same thing except for x e to the x. So it's That is so awful. Cool, so now we know what product log is. Product log of log. Is it now? Natural, okay, E to the... Oh, even I hate that. Oh, this will be a pain. Okay, so... And I'm pretty certain you can do it for any n. Please tell me you can do it for any n is equal to n. Please tell me there's a rule to it. There has to be a rule. Let's be real, there has to be a rule. I don't like that I said, you know, there has to be a rule, and the music said, not a chance, fella, not a chance. We might have to watch this video. We might have to watch this video.
Complex numbers, we can put
It feels so bad to steal content. Let me just... effing massive text. Let me just... with this text... wait. It's like... Here we go, no. No, let's add a couple more. Hi there! I'm trying to watch a video to understand how the product log works, but I don't want to steal content. I'm writing a... oh, wait, no. Yes, I'm writing a paper. Because this would basically... what I need to do... Yeah. What I need to do is I need to solve x to the x is equal to n. Product log. Exactly. Well, I need to solve x dx is equal to n. Which I guess could be e to the... I need to solve it for x. This is bullshit, it can only be done with a computer. Yes! Well, that is one way to put it. That is true. And because of that, I need product. Well, here's the thing. I am trying to do the impossible. I am inventing type of mathematics in which it would be possible to do it without a computer. But for that, I do need to know how to do it with the computer. Go around academia, link some papers. I mean, I feel like I should just go with 3 blue and brown. I mean, let's be real. I'm sorry, Crimpy, for this content barrier, but I don't want to be stealing content.
put on W of Z.
So there's
But
this
anyway,
content barrier.
this
here.
is defined to be
Let me just increase the content barrier effectiveness. Like this? No, wait, that didn't do nothing. When there's no serious approximation, I would love to give up. Is it effective? It's not yet. Let's change it to something 6 to like. I remember I was trying to find out about this quite some time ago. It's like it exists, but it's very different. I know it's a pain. I know because I've tried. It's Lambert double function. Yeah, I tried to figure out months ago when I was actually curious about XDX, but right now I don't need the exact number, so that's convenient. For x is greater than 60, there is a great approximation out there. You know that the function is great if you say stuff like, no, for x is greater than 60, there is a great approximation. but just zero sucks. Oh yeah, this sounds
inverse
really good.
of a specific function.
Yep.
And that function is x times e to the x.
Right, we are
And
also
as we all
doing it
know,
on double
the
speed.
inverse of e to the x, that's just a natural log, but that's not enough when you're trying to solve an equation like this. So, if you have like function like x times e to x, we are going to define the inverse of this to be the inverse w function.
Yeah,
And I'm going to
I
write
know.
down two important properties for the w of x. The first thing is that you have to remember w and f, they are the inverse of each other. So if you enter
Yes.
f of x into w,
give us
they
x
pretty much
and
cancel
not
out and
x.
just get x back. And
Yeah,
you see,
that
I'm not going to
x,
talk about the domain
sorry,
because that'll be too long.
sorry.
That'll be for my future videos. So for all the examples,
I will be talking over constantly, and I will not remove the content barrier because I do believe that rebooting of all the videos on live streams is the wrong thing. So there will be no enjoyment in
You're
watching
nice,
that
right?
for anyone.
anyway, let me actually write this down right here.
Yes.
So when you have w of f of x is x times e to the x,
Yep.
the beauty when you are looking at this is when you have this and that being the same and e for the base, and you apply w for that, you are going to just get this right here.
Yes.
Why? Because once you get w and f, they pretty much cancel, you just get the x back. But this expression you should keep in mind, we'll be using that a lot. And the second property is, well, I can enter w into f. So I can put down f first like this, and then we'll enter w of x like that. Once again, because they are the inverse of each other, so you know this is going to just give you x.
Yes.
And this time, I will just put the w of x, this thing, into this x and x, because I'm trying to enter w of x into f. So this is going to be w of x right here first, times e to the w of x again, like that. And of course, if you have this expression, this is still going to give you x. And we actually like to divide the w of x on both sides, so we actually get this nice property, e to the w of x being x
X
over
times-
w
yeah.
of x, like that. Once again, keep this in mind. Now, let's talk about how
Yeah,
to
I
use
will.
all this to solve x to x is equal to. Well, I will first get rid of this exponent. Then to do that, I will just take both sides and raise that to the 1 over x power. So on the left hand side, we'll just get x right here. And on the right hand side, we have the number 2 raised to
yes.
the 1 over x power. Here, the base is 2, but we don't want base 2. We want to work with base e. So I will look at this 2 right here as e to the ln2, like that. E and ln cancel, so you know this is just the same as 2. And now let me write down rest. This is x equal, then it is 1 over x right here. And you see this is the power, we can just multiply with that power. So we have x equals,
Okay, so far, everything makes sense. Which yeah, we can have x is equal to e to the natural log of n, 1 divided by x, which means that I'm pretty certain we can. Yeah, I mean, generalized stuff should be easy. Yes. Okay.
e, and then ln2 times 1 over x is just
I'll just go
ln2
step by step and
over x
check
like
if
that.
that is
So now,
exactly the case.
this is the power that we have for the e, and that's pretty much this. I want to have the same thing in the front. Well, first of all, let me just write this down better. I want to have the same thing in the front, right? So what can I do? Okay, I can just multiply both sides by ln2 over x. That's going to be so nice. Why? Because yes, I will multiply by ln2 over x here, and I will also multiply by ln2 over x here. So nice. This and that cancel each other out. So in fact, we just
Alright, so this does work so far. ln of n can be equal to natural log of n divided by x, e to the natural log of n divided by x. So far it works, so that's great. Cool.
oh yes, on the left hand side now. So wonderful. Well, here we have ln2 on the left hand side, and that's equal to, this is just ln2 over x times e raised to the ln2 over x power. And this is exactly the formula we want. Once again, you see the front and the exponent, they are the same. Then I can actually apply the w function on both sides. And you see, the left hand side is just a nice number. So let's go ahead and do that. Let's take w of this and also take w of that. On the left
Yeah.
side, this is just w of ln2, and this is a nice number. You can just use a calculator to calculate that.
This is a nice number. Glad.
On the right hand side, so you see this and that.
Wait, this will give us natural log of 2 divided by x over here. All this will cancel with natural log of 2
Then
divided by
you
x,
apply
right?
w to that. Look at this right here.
Natural
This is
log
what I'm
of
saying, and you apply
n
w to
divided
this
by
to
x.
just get the x back right here, right? So in this situation, the right hand side is just ln2 over x. That's very nice.
Yeah.
As you can
Oh,
see,
okay, that's great. Oh, I'm so forgetting. That was all for comedic value.
we only have the x right here. So of course we can solve for x nicely. So I'll just take the reciprocal on both sides. And I'm going to write this down first. We will have x on the top over ln2, and that's equal to, this will be in the denominator now, so it's 1 over w of ln2, like this.
So it's natural log of n divided by w, natural log of n.
And of course we can now just multiply by ln2 on both sides.
Cool.
So we see x, that's pretty much it. Well, notice,
Yeah, great. Back to the paper. Oh, come on. So that means that over here, this will be equal to I can remove the content blocker. Fraction of natural log of n by w natural log of n. So 1, 2, 3, 4. Okay, great. And now over here, let's add these. Now we can get into the problem and the expected solution to it in this paper. We can see that any half, that any h of n of x, wait no, that's inside hat, that's wrong, of x will be equal to, well, it will be equal to the, let's do it in brackets, inverse of an equation with of an up arrow and up arrow equation. Left side of approximation holds true for x greater than 49.93. I know, I get it. But that's the okay. I should probably explain what I'm doing here. So basically, right here we have, this is okay. Right now I can tell you what would be great and what's holding me back when it comes to this. So what would be great is that if we actually create this, I call it hyperoperational mathematics. If we actually create this field, then over here we wouldn't need to use approximations. We would know the exact value. Well, not the exact value, but we would know it without approximating it like we, using W function and stuff like this. We would know it in a more convenient way. Because we know that this would be based on titration. We know for a fact that this would be based on titration. The thing that's holding us back is that all of these are kind of problematic. This one uses division, this one uses roots, this one we don't know yet. And in this field, division, okay, I should probably write that down. So if we just find the appropriate inverse of titration, then we will be able to have a nicer answer. I love wheel and field theory, but I doubt I can help inventing it. Here's the thing, that's what's really nice about this. I'm creating my own field, which means I get to make the rules. This is not mathematics. This is a thought experiment, which is different kind of mathematics. It's not normal mathematics. It has only 3 axioms. One of them